Black holes, the enigmatic wonders of space, have intrigued scientists and the public alike for years. Their unparalleled gravitational pull and mysterious nature defy our understanding of physics. But the James Webb Telescope finally captured what's inside a black hole. First, let's review the basics of a black hole. Imagine a space region so strong that nothing can escape its pull, not even light. That's a black hole for you. It comes into existence when massive stars run out of fuel and collapse under their own gravity. This collapse continues until the star's matter is squeezed into a tiny, super-dense area called a singularity, surrounded by an event horizon. The event horizon is like a point of no return. Anything that crosses it can never escape the black hole. There are different kinds of black holes based on their size and how they were created. For example, supermassive black holes like the one in our Milky Way galaxy come from the collapsed cores of massive stars. Other theoretical black holes are either smaller or larger. However, we were never able to get inside it until the James Webb Telescope finally captured what's inside a black hole. Now, black holes are not just sitting idly in space. They have an accretion disk, a spinning disk of super hot matter that eats up gas, dust, and sometimes even stars that wander too close. Occasionally, they shoot out particles and radiation in powerful jets. The biggest black hole known to us is a bit of a space riddle. So far, there doesn't seem to be a limit to how big black holes can get. Yet, scientists think there's a maximum size for black holes, and the biggest one ever spotted, Ton 618, is just below this limit. It's truly monstrous. Its mass is about 40 billion times that of our Sun. Ton 618's light output is powered by a quasar, one of the brightest objects in the universe, which is about 18.2 billion light-years away from Earth. Here's a fun fact. Quasars are actually supermassive black holes in the making. By constantly eating matter and merging with other black holes, they grow huge. But there's a limit to how much they can eat in a certain time, which gives us an idea of their maximum size. When matter falls into a black hole and gets heated up, it emits radiation, which in turn slows down more matter from falling in. This check and balance stops black holes from growing too quickly. The James Webb Space Telescope recently spotted a black hole in a young galaxy, making it potentially the oldest known black hole. It's a biggie too, with a mass 10 million times that of the Sun. The exciting part is, this discovery might be just the start of a new era of black hole discoveries. With the telescope's capabilities, we might find even more black holes from the early universe, around 100 million years after the Big Bang. But the big question is, why were there so many black holes back then? And how did they get so big? Scientists are still figuring this one out. To find the universe's oldest black hole, scientists use a giant space telescope, the James Webb Space Telescope. It's like a super-powered detective looking at light from the deepest corners of the universe to find clues. They found hints of a black hole, giving off a weak signal like a tiny flashlight in the vast darkness of space. Scientists have two big guesses about how black holes started right after the Big Bang. One guess is they came from old, massive stars that were born and died much faster than the stars we see today. Another guess is that they sprang from super dense gas clouds that suddenly collapsed, creating black holes. Rebecca Larson, a smart scientist, thinks they might have started from a massive explosion of the universe's first star around 200 million years after the Big Bang. That explosion could have left behind a baby black hole, which quickly grew by gobbling up loads of stuff around it. Now, the scientists keep looking at light from far-off galaxies to learn more about our galaxy's very own black hole. Every new discovery is like a piece of a giant puzzle about the universe's beginnings and its strange creatures. One of those strange creatures might be a black hole that seems to be looking straight at us. It was thought to be a radio galaxy, but the angle has changed massively by a whopping 90 degrees. Now, this black hole's powerful jets of high-energy particles are pointing right at us and zooming out radiation at almost the speed of light. Because of this huge shift, scientists now think it might be a blazar, a special type of galaxy with jets aimed right at us. Why this massive change? Maybe a collision with another galaxy knocked it off course. Scientists will keep digging to solve this head-scratcher. But that's not all. Another amazing discovery could shake up what we think we know about black holes. Scientists may have found hints that invisible dark matter, a mysterious stuff thought to make up most of the universe, surrounds black holes. To find this out, scientists in Hong Kong watched stars orbiting around black holes. These stars seem to slow down a tiny bit every year. The researchers think it's because dark matter is creating a drag, like trying to walk through deep water. They used a powerful computer simulation to test this, and it lined up with what they saw. Manho, the team leader and professor, believes this is the first study to provide strong hints that black holes could be surrounded by dark matter. This adds weight to the idea that black holes can pull in and consume dark matter. Their findings, like another piece in our giant puzzle, help us get closer to understanding our incredible, ever-changing universe. There's an exciting development in the realm of space science that's making waves. Imagine, if you will, a group of researchers armed with a unique instrument, unlocking the secrets of the universe that have been out of reach until now. Scientists from the Education University of Hong Kong have found a new way to peer into the dark void of space, unraveling the enigma of dark matter distribution around black holes, and thereby opening a world of potential discoveries. This new approach could change our quest for knowledge about the universe as we know it. The dedicated team of researchers aims to keep the ball rolling, on the hunt for more black hole binary systems similar to the ones they've been studying. Sean, one of the diligent researchers involved in the study, asserts that this exploration will open up a whole new avenue in dark matter research. In our very own Milky Way galaxy, there are at least 18 binary systems of the same kind. Each of these cosmic structures can potentially help us unravel the mystery surrounding dark matter, a substance as elusive as it is intriguing. Another important stride has been made with the help of the James Webb Space Telescope. This eye in the sky spotted something extraordinary in October 2022. Unique molecules called polycyclic aromatic hydrocarbons, PAHs, orbiting supermassive black holes in 3 different galaxies. Now, these molecules are not uncommon in areas of space where stars are being born, but seeing them around black holes was completely unexpected. The commonly held belief was that these molecules would be obliterated in the harsh environment near black holes. This revelation is nothing short of astounding, suggesting that the radiation near these black holes may influence the properties of PAHs. This could pose challenges for astronomers trying to understand star formation, as well as reducing the utility of these molecules as building blocks of life. A team led by Ismael Garcia Bernidi, an astrophysicist from Oxford University, dug deeper into this enigma, examining mid-infrared observations from 3 active galaxies millions of light-years away in various constellations: NGC 6552, NGC 7319, and NGC 7469. The PAHs, carbon-based molecules widespread in the cosmos, play a crucial role in star formation. They emit a strong infrared wavelength when they interact with ultraviolet radiation present in starlight, a phenomenon that MIRI can detect. Garcia Bernidi sought to discover if the PAH emissions near the center of active galaxies, rich in ultraviolet radiation, were similar to those in quieter star-forming regions. This ultraviolet light is produced when gas falls onto a supermassive black hole, which triggers a fluorescent glow in the PAHs. Click the subscribe button to get such regular updates. Contrary to previous theories that suggested that the intense radiation around black holes would annihilate all PAH molecules, MIRI detected an abundance of larger, electrically neutral PAHs in the center of the 3 galaxies. This suggests that the smaller, electrically charged PAHs were indeed wiped out by radiation, potentially because molecular gas clouds protected the larger PAHs. This revelation presents a challenge, as smaller charged PAHs are usually found in star-forming regions. However, by examining more active galaxies with varying properties, astronomers might gain valuable insights about the unique properties of PAHs in the core region of galaxies. This data is of paramount importance to comprehend the rate of star formation in galaxies and their evolution over time. Watch this video on screen to explore the depths of space with HD images, revealing the incredible wonders that exist out there. The James Webb Telescope has groundbreaking discoveries to share through captivating documentaries.